Hey there, everyone. Ryan Schul here. So the narrative today is going to focus on obesity in the United States, and we're going to plot the results of some obesity analysis that was done on a map of the United States, and where states have residents are typically more obese, where there's more prevalence of this occurrence, then these shapes are going to become more distorted and larger, and where people are more healthy and less obese, then the shape of the state is going to be smaller. Okay, so we're just going to experiment with some cartograms and just how we can distort these shapes to sort of highlight certain areas, in this case, obesity in the state, or either excessive obesity or less obesity, which is more healthy, right? So we're going to look at volatility and uncertainty, prioritization, where bigger shapes naturally represent people that are more obese in that state, right? And then once we build the charts and the graphs, it should become very evident and very apparent, which states are the most obese by the distortion of the shape of the state. Okay, so I haven't seen anything like this. I just had this idea just come out of the blue a few days ago, and I thought it would be just a fun little task to work on. So I did find this data online. I just did a quick search. The data source was here. Okay, you can see what the end result looks like, right? It looks like a little bit distorted shapes of the United States, but not hugely distorted. Okay, so here's the data source. They have a nice normal map over here. California is pretty healthy. New York, Vermont, Connecticut, pretty healthy. Arkansas or Mississippi, not quite so healthy. Okay, and if we go down here, they have this little control tool that you can drop down, and you can see the prevalence. This, I guess they are referring to the occurrence of obesity, and they have a confidence interval from 37.3 to 41.3, with 39.2 being the mean. I think that's how they're doing it. That's my interpretation of this. So we have the state, we have the prevalence, and we have the 95% confidence interval. So that was the basis for my analysis. I copied and pasted that over here. So if I go to Control Enter and run the cell, we have the basic setup here: Plotly Express, string IOs, pandas. I use pandas for almost every job that I do. So this is just to disable errors. Sometimes you get these little errors that pop up that are kind of innocuous. Sometimes helpful, though. They'll tell you if one library is going to be changing or being updated, or maybe become obsolete sometime soon, and that's kind of good to know, but I feel like it's more annoying than more helpful most of the time. So I'm going to go ahead and parse out some information here. So we have the prevalence that we saw on the last page, and we have the confidence interval, right? So we go from 34.5 on the lower end to 37.7. 37.4 on the high end, and 36.0 is the mean. All right, so we just handle these and just copy and paste it just as we saw in that example on that web page. And then just doing some basic cleanup here. So regex matching and looking for just ways to clean up that data and just make it a little bit easier to work with. Okay, so we have the prevalence number, the confidence interval low. They call it CI high, and then the width will be the difference between the high and low. So pretty basic math. So I'm actually creating a dictionary of key value pairs here. When you see these curly braces, this means dictionary, and the key is going to be over here, and the value is going to be to the right of the colon. So here's Alaska, the value is AK, the key here is Arizona, and the value is AZ. And you can see the distinction here. After the colon, you have the state abbreviation, and we need this for Plotly. So we already had all the state names over here. We have all the names listed, very nice, very well structured, very orderly. But unfortunately, or for whatever reason, Plotly only takes state abbreviation names, so we have to convert that, right? So that's why I had to add this small script in here with the dictionary. And I wanted to kind of break this out a little bit. You don't have to do this, but I think this is a nice thing to have, where you have regions broken out: Northeast, Midwest, Southwest, and then territories of the United States: Puerto Rico, Guam, and Virgin Islands. And I don't even know if they had any information on those three. Let me go back and see. Oh, they do have some of this. Okay. do have a bit, okay? Oh, look back here. Okay, so this site is a little bit unstable. And by the way, some of these states have insufficient data, right? So if the data doesn't exist, we have to interpolate that. So I'm going to use just a basic mean interpolation method. I think that's fine. In this case, there's many ways to do this. You can actually use data science to do the interpolation. You can use mean mode, fill forward, fill back. I don't think that makes a whole lot of sense, fill forward and fill back, just because if you did that, if you fill forward, you would take the obesity number from District of Columbia for Florida, or if you fill back, you would take the Georgia obesity prevalence number from Georgia would become Florida's obesity. And you can see the deviation between these two, so I don't think it makes any sense. It's more of a mean interpretation, but there's a few ways to handle that, right? There's a couple data science techniques using things, either a regressor, maybe a classifier. This is not a classification type of problem, or maybe even, yeah, when I think about it, probably regression would probably be the best to solve that. Okay, so we do a little more cleanup down here, and this is what we end up with. So we start, remember, with this data set right here. If I print this, DISPLAY, you can see that very little work was done up to this point. I can cut this out. This might be a little easier to interpret if I do it like this. I can cut this, put this into a new cell, and that is fine. Okay, I'm going to update this and rerun this process. So I'm going to clean that up just a bit. I like to keep run a tight ship here. So this was the original view right here. If I do everything, I might as well just do everything, right? Because then you can see where the data was missing from. So no data here, no data here, right? So those have to be interpolated, and we have to handle this state abbreviation naming convention for Plotly, and then we have to do this regional mapping, then eventually the cleanup of the data. So when I run this, I end up from this very basic data frame with just a name, prevalence, and confidence interval over here to do some, just a little bit of feature engineering, nothing heavy duty, but we have the prevalence 95% confidence interval. Then we clean this up a little bit. So we have the prevalence number, which is basically the same thing, right? It's just kind of cleaned a little bit. And you can see that this is a float number over here. I think it is. Sometimes these come in as strings or text. So it is good to have an actual number, especially if you're doing some type of analytical calculations on this. So this is confidence interval low, confidence interval high. So that is basically 37.3 and 41.3. And it's just split into separate and distinct columns. It's just a lot easier to work with data in this format. If everything is jammed up into one single column, like I've seen data come in where all of this is in one single column, right? You don't want that. You want the data refined, cleaned up in a nice, decent state so you can actually do some analysis. If it comes in all jammed up into one single column or just a couple of columns, it's going to be way harder to work with. And eventually you have to break this out. Like somehow you have to break this out. So you have the state abbreviation name. That's going to help immensely when we put this into Plotly. You have the region, right? I think that's pretty helpful. North, south, east, west, things like that. And is this imputed value? Yes or no? These are mostly false, although you do have a true down here because there is no data, right? If we go over here for Pennsylvania, there's no data. So this was imputed value, okay? Just so we have peace of mind, we know what's going on, and everything is arranged and organized pretty well there. So if I run this, we can see originally Kentucky and Pennsylvania were imputed, and the prevalence number becomes 35.4, and this is 30.71, okay? So basically, let me see. Let me just look at this. Imputed. Yeah, so this is where the imputed row comes from. If false, then there's nothing to do. Yeah, so that's it, guys. So anything that's imputed equals false, we have to do the imputation ourselves. If it's true, if row equals false, if not false, I'm sorry. So yeah, this probably could have been done a little bit better. That's fine. If not false, then we do the imputation. If imputed equals false, then there's nothing to do, right? So I think we saw 2 rows. What was it? Kentucky and Pennsylvania or something like that. Yeah, there's no data. So if that is not false, that's true. And for Kentucky, so here, so the imputation is done by taking the median number, which is basically a natural median for that state. Okay, so it should be a pretty close approximation of what the prevalence number should be. So, okay, so I think we're in good shape here. Let me get rid of that just to make it easier to read. So 2 are imputed. The numbers are coming in at 35.4 and 30.71. I think that looks okay. Now we're going to take everything and push this into a choropleth map. So these choropleth maps are pretty cool. If you look at an example, okay, there's a data source. Let me get rid of this. They have some nice examples on their website. And these are useful for so many different things. Any kind of mapping to geographical regions, right? This, I think, is called a FIPS map. So this is based on, what was this? I looked at this a while ago. I think this is based on counties in the United States, right? And you can zoom in. You can see all the details of the different counties in different states, and you can see how the colors correspond to the numbers on the right. So in this case, a 12 is going to be a higher number and a lighter color. And I think this data is basically, what are they looking at? I think this one was unemployment or something like that. Yeah, unemployment. Okay, so that was unemployment. So anyways, just to showcase like a few things you can do with this. This is Canada. Again, lighter is a higher number, darker is a lower number. And there's all kinds of cool stuff that you can do with that. So that was my inspiration for this map. So if you just go ahead and if you just look at the examples I have, it's pretty straightforward, guys. You can copy and paste this into your notebook pretty easily and run it. So they are looking for, let me find one of the easier ones. So you have the data frame right here. This is, the next feature is the type of the data. I think that's how they do it over here. Let me see how they set up in the previous data. And then, the field, right? The field in the data set that you're looking at. Location is going to be FIPS, and color is going to be some kind of unemployment color, which comes from this data set. So I believe these two got merged together, or they're just using it. No, they're just using it straight up. So this is the data frame, this is the source, and this is the county. Counties is the feature name or the column name. So I'm doing the same thing over here. So to map is my data source, locations is going to be the abbreviation that comes from over here, right? And I told you before, in the choropleth map, you need a state abbreviation. It doesn't take state names, right? So you saw how we got that from the dictionary. Locations is going to be USA states. Color is going to be prevalence number. Okay, so the prevalence number, remember, represents the intensity or the number of obese people in the state, with higher being more obesity and lower being less obesity. And we're going to use a shade of red. There's all kinds of different color options. You have reds, yellows, blues, and greens. You have combinations, red, whites, and blues, and ice. I think it's called ice or something like that. Okay, and then I just have a small dictionary down here saying hover data is the state and imputed and then the abbreviation. So that's how we get these things. So pretty straightforward just to set up the basic choropleth map. There's not a whole lot to it. Here's California. Colorado is pretty healthy. I think it has the lowest prevalence, 24.9. New York is pretty healthy. Vermont, Connecticut, Massachusetts, New Jersey is actually pretty healthy, even though when you drive through there, it doesn't look like it's healthy. And California, it looks like it's in good shape. These darker states down here are states where just contains more obese people for whatever reason. I mean, I think I have a couple theories. I'm not going to talk about it here, but the prevalence is definitely higher. These numbers are higher. This is 40.0. West Virginia is 41.0. Louisiana is 39.9. So definitely in the ballpark of its neighbor there, and 40.1. So you have 40, 40.1, 39.9. Okay, and Hawaii seems to be pretty healthy. And Alaska over here, seems to be kind of in between, right? So the basic choropleth map is pretty easy. You just pop in those numbers, just like I showed you right here, right? And everything gets built. It's pretty fast, pretty easy to do. I don't even think I refreshed it, did I? Let me refresh the data. Right, so we have the map. So the goal here, like I said before, was to create a distorted map to show states that have more distortion are going to be a little bit bigger and a little bit more bloated, almost like an obese person is, and not to poke fun at obese people or anything. I just had this idea like bigger state or a bigger person in the state can be represented by a bigger state shape, and if it's more healthy, it can have a smaller state shape. That was the goal here. So not to be mean or offensive or anything of that nature, just to illustrate the point of how we can create a distorted plotly map using choropleth. So that was the thing I had to get. State provinces, I found a data source over here. So I had to read that in and get a list of abbreviated states that are not in the main United States. Because remember, we had things like Guam, Puerto Rico, I think Virgin Islands was the third one over there. So those are going to be removed. And this is VI, this is Guam, Puerto Rico, and there's a couple others that kind of popped up. I think it came from this data source, actually, that are somehow also territories of the United States. I don't know if I've heard of that, but they didn't seem like real state names. Like Vermont would be VT, VI is going to be Virgin Islands. So if it goes into this category, like AS, I don't know what kind of state that is, but it doesn't seem like it belongs. If you look over here, we have AL, AK, AZ, AR. So we have 4 state abbreviations that start with an A. So if you see an AS in your data, like you have to kick that out. You have to get rid of it because that doesn't belong there, right? So we go ahead and create basic geometry, and this is going to help us create the states that look essentially kind of like their original state shapes, but it's going to be more bloated if it's containing more higher incidence or higher probability of obesity, and it's going to be smaller if it has, what do they call it? Oh, prevalence, the prevalence number. So if the propensity for obesity is greater or the prevalence number is larger, the state is going to be more distorted and more blown up. And then if it's smaller, it's going to be the opposite. So that's the goal here. We have a distortion block where I'm creating some angles and some geometric manipulations down here. And again, there's a couple of states that we have to handle specifically, Alaska and Hawaii. I'm taking that just to kind of condense everything to a relative scale. Like when you look at this, you're going to see a very shrunken down Alaska. That was kind of intentional because otherwise Alaska is way up in the northwest. And it looks kind of funny when the United States is way down in the southeast and the whole United States is southeast. And then you have Alaska, which is, I think, half the size of the entire lower 8 continental, what's it called, contiguous states or something, lower 48 states. And then you have Alaska. The whole distortion thing gets really distorted and looks really weird. I don't think we want that. I just want to kind of control for that variable. And Hawaii is the same. It's going to be way, way, way off in the Pacific Ocean. And it's going to look tiny relative to Alaska and relative to the United States. We don't want to create something that's very confusing and very deliberately off-putting for the audience, right? We want the key stakeholders to be happy with the outcome, and they tested a few ideas. And I'll be honest, I went through several iterations. This took a long time to put all the code together, but the final version, I think, came out pretty nice. So there was a couple outliers I had to handle over here, and these guys over here, it just doesn't look like it belongs. And I've never heard of AS as a state or as a territory of the United States, so I just thought, just kick it out. But if you do the analysis and you want to include that, by all means, you can do that. So I just ran the update here. I think it ran. Okay, so just like before, we're taking all of the inputs, like I showed you, into that plotly map and setting up everything. So we have the coordinates, we have the reds, we have the locations. These are the state abbreviations. Again, state abbreviations, and we just keep on building and building and building this choropleth map. So the second one, because of all the distortions, takes a little more work. The first one is pretty easy. Like the entire thing consists of this, and some of these things are actually optional. You don't even need this. It looks nice when you put the mouse over it. I think it looks nice, so I added those in. But some of these things you don't even need. When you get to like a more creative type of map, you can do almost anything using Plotly, maps or choropleth maps or any kind of plotly chart at all, if you think about it, they have all kinds of different plotting samples here. I can just take you through. I really like this stuff a lot. I'm pretty excited about it. So docs product example. I haven't looked at this in a while. Let me see. This has definitely changed since the last time I looked at it. Plotly. Okay, so this might, oh, that's take me just to maps. That's fine. You can see a bunch of maps here. These are Plotly maps. And again, you can zoom in, zoom out, get all kinds of details for all of these maps. Right, so it's pretty comprehensive. The coverage is pretty nice there. But I want to show you like a lot of these other kind of plots that aren't just map plots. Plotly sample data sets. Maybe this is it. I think this has changed. I don't think that's it. Okay. Has choropleth only, so that's not really what I'm looking for. Well, I don't want to waste a lot of time here. The site has definitely changed since the last time I looked at this stuff. And I don't know. Python crafting library. Oh, okay. This is kind of what I was looking for. Okay. So anyways, just quick overview. I won't spend more than a minute. They have all kinds of scatter plots, line charts, bar charts, histograms, box plots, heat maps. Like we saw before, these are the maps of the United States, maps of the whole world. Okay. Machine learning, use cases, bioinformatics, 3D charts. Those are pretty cool. And subplots that go inside of the chart. And they even have slider controls and a few other things like time series animation graphs. So these things are cool too. I would definitely check this out when you have a chance. This is the animation plot. These things are very cool. Again, all you need is this px scatter. This is your data frame. This is the name of the x variable. This is the name of the y variable. These are just columns in your data. The animation frame is another column in the data. Animation group. So this is taking everything, grouping it. The size of the disk here, or the diameter of the circle, is going to be population, color is continent, and hover name is country. And they're using a log control here, set to true, just to get everything in the same relative scale. Otherwise, like the huge countries like China are going to kind of blow up this whole plot and kind of overtake the whole thing. Okay, so that's that. I think that's a good introduction to charts. Let's get on with the analysis. So everything ran. We have the United States. This is the final product over here. So you can see California is kind of shrunken from the original value because people are basically more healthy, and the state shape corresponds to the health. Just think a healthy person is going to be smaller. And again, I don't want to be offensive here. I'm just saying, like, if people are overweight and obese, it's going to be bigger. If people are smaller and healthy, it's just smaller, right? That's the way it is. So Colorado is smaller. New York, Vermont, Connecticut, Massachusetts, all smaller. New Jersey, pretty small. West Virginia is bigger, right? You can see that looks weird. And if you look at the state shapes, they look weird compared to the normal state, okay? Florida is a little bit smaller, so that's in shape. Michigan, Wisconsin, not really in shape. North Dakota, not really in shape. And Alaska is kind of in between. They kind of do their own thing. And Hawaii is right there. So that's it, guys. So I think we beat that horse to death. I think mission accomplished here. We achieved the goal that we set out to do. I am going to save this script and share it with you like I do for all of these things, right? So you can take it, run it in your own Jupyter notebook, and just learn from these examples, right? Go ahead and make changes to the code, break it apart, put it back together, do some engineering, and then reassemble it. That's the best way to learn these things, right? If you just take it and run it, you'll learn a little bit, but bare minimum, if you take it and make a bunch of mistakes and then fix the mistakes you make, you're going to learn a ton more, okay? So I would encourage you to really get engaged with this stuff if you have a passion for it. If you don't, then that's fine. But if you want to learn this stuff, spend some time with it. That's what you have to do. You have to spend some time with it, okay? So that's it. I have my download. I'm going to post this video and a couple others I made recently. I'll drop everything on YouTube a little bit later, and you can go check out the videos, and you'll have all the source code as well. Okay, so that's it. I'm going to sign off now. Thanks for everything, and I'll see you guys in the next one. Goodbye.